Okay, number 22 says give the parallel and perpendicular slope for each of the following. Okay, so if they're parallel lines, we know that they have the same slope. If they're perpendicular lines, we know they're going to be opposite reciprocals. Right? So if I look at number 22, the slope for number 22 is 1/4, right? So the parallel slope would need to be the same, which is 1/4. The perpendicular slope would need to be the opposite, which means it's negative, and then the reciprocal part of that means I'm going to flip it over, so it'll be a -4. Okay, the slope on this one, if I start at this point and I go up to this point, I'm counting 1, 2, 3, 4, and then over 2. So the given slope is going to be 4/2, which reduces to 2, right? So then I need the parallel slope. And the parallel slope would be the same. The perpendicular slope, opposite reciprocal, so negative, and then 2 becomes 1/2 when you flip it over. My last one, if I start here and I count up to this point, I'm going to go up 1 and over 1, 2, 3. So I'll put it up here. The slope is a positive 1/3. So my parallel slope needs to be the same thing, which is be 1/3. My perpendicular slope is going to be opposite reciprocal, so -3/1 or just -3. Okay, number 25 just says, which inequality will match the following graph? So let's look at our clues here. 1, 2, 3, 4. This is at -4. So that means my y-intercept is -4. Well, if you'll notice, all of them say -4, right? Then it says all of my slopes are also going to be the same. Look, they're all +2. So really, I just need to look at my inequality signs. Is this a dashed line or a solid line? It looks like it's a dashed line. So that means it's not going to have the equal to. So this one right here, A that has the equal to, not it. C that has the equal to, not it. And then where are we shading from this point? Our y-intercept, are we shading above or below? We are shading above. That means it should be a greater than sign. So it looks like B is going to be the correct answer. Okay, number 26 says, which of the following is not a reasonable solution to the following inequality? So in order to figure that out, I need to go ahead and simplify this. So I am going to distribute to eliminate parentheses. So I will have 5x plus 5 greater than or equal to 30. I need to move this 5 over by subtracting 5 from both sides. So this is gone. It leaves me 5x greater than or equal to 30 minus 5 will be 25. And the last step, I'm going to divide both sides of my inequality problem by 5. So the 5 is gone. It leaves an x. 25 divided by 5 will be 5. And the big question is, do I leave my inequality sign or do I flip? Again, I did not multiply or divide by a negative, so the inequality sign stays. So this reads x is greater than or equal to 5. So let's see what my answer choices are. F says 7. Is 7 greater than or equal to 5? Yes, it is. But remember, we're trying to find the one that's not a reasonable solution. This one will work. G also is 7, so of course that's still the same. Yes. 14, is 14 greater than or equal to 5? Yes, that's true, so that's not going to be it. How about 2? Is 2 greater than or equal to 5? Well, no, of course it's not. That's false. That's the one that we were looking for, the one that's not going to work. All right, number 27. A drama club must sell at least $1,500 worth of tickets to cover the expenses of producing a play. If adult tickets X cost $10 and student tickets Y cost $6, write an inequality that would find the amount of adult tickets and student tickets that must be sold to cover the costs of the play. Okay, so it just says to write an inequality. We're not solving it. So adult tickets are going to be represented by an X and they cost $10. So that means 10 times the number of adult tickets. Student tickets are going to be Y, and they cost $6. So we're going to add the number of student tickets at $6 a piece. And then all of this needs to be at least, here's that, at least $1,500. So that means this has to be at least that amount. It could be more than, but it can't be less than, otherwise we're not going to hit our the amount that we need. So it'll be greater than or equal to $1,500. Okay, number 28 says the clothing store sells t-shirts X for $20 and skirts Y for $25. The store wants to sell a minimum of $800 worth of t-shirts and skirts. Write another inequality that could be used to find the number of t-shirts and skirts they must sell. Okay, so again, we're just writing an inequality. So they're selling t-shirts, they're letting that be X, and they sell for $20 a piece. So again, 20 times X, the number of t-shirts. And they're selling skirts Y for $25 a piece. So again, we're going to add the $25 for each skirt, which is going to be Y. And the store wants to sell a minimum of $800. So again, this needs to be greater than or equal to the $800. And we are done. All right, number 29, it says give a graph for each of the following strengths of correlation coefficient. Okay, so remember the correlation coefficient was that R value that we found in the calculator, and the closer it was to 1 or -1, the stronger the correlation was. So if we are trying to show a strong positive correlation, let me draw these graphs real fast. Okay, so here's X and then Y. And my last one. All right, so if like the first one says a strong positive, well, positive, of course, is going to be going up like this, right? And a strong one means it's going to practically make a line. Like it's not exactly a line, but very close to a line. A weak positive means it's still going up, but it might not be quite as close to a solid line going through there. A strong negative, of course, again, we're going down, and it would be very, very close to being one solid straight line. A weak negative, again, we're going down, but it might not be quite as close together to make one line. Okay, number 30, you can't see the entire question on here, but basically they've given you 4 graphs, and then they've given you 4 situations, and they were wanting you to match the situation to the graph. So the first one says Kelly and Cindy sprinted from one end of the gym to the other end. Then they jogged back to where they started, and then Cindy sprinted faster than Kelly. Okay, so Cindy and Kelly are sprinting. So they're starting one place and they're returning. So this one, they're starting here, and this is the amount of distance from the start. So they're starting here, but they're not returning here, are they? So we know A's not it. This one, it doesn't look like here. If it looks like they're moving, but then here it looks like they've stopped because they haven't. The distance again hasn't changed, and then they do return, but they've stopped. It doesn't say anything about them stopping. So this one, it looks like they kind of are going at the same rate. Like as fast as I'm going this direction, I'm going the same speed going the other direction. I don't think that would be it. This one looks a little better. Like I go really quickly and then I go a little slower getting back to my beginning. So I'm thinking this is the first one, and it kind of looks like an ink blot type thing. I'm just going to make a little star. Okay, so that would be for the first one. The second one says John walked to school. The second half of his walk was uphill, so he walked at a slower pace. So he's not returning. So the only one here that's not returning to where they're starting would be this one. So this is going to be the block, or the square rather. The next one, it says Rachel drove to the dentist office. Her appointment lasted for 45 minutes, and then she headed home. So that would be this one, where she went somewhere, she stayed there for a little while, and then she came back home. So this one was the third one. That was an arrow. So that leaves the last one. Mike and Ron rode their bikes from Middletown to Centerville and then back. Soon after they began riding, Mike was ahead of John. So this definitely would be the star. That's right. 31 says, the orchestra in Wild Grove is putting on a benefit concert for the local children's hospital. Orchestra seats cost $57 per ticket and balcony seating is $110. The goal is to raise at least $7,200 for the hospital. Write an inequality that describes the situation if 0 or the letter O equals the number of orchestra seats and B equals the number of balcony seats. So again, we're just writing an inequality. This time we're letting O be the number of orchestra seats and B the number of balcony. Okay, so if O is orchestra, how much were the orchestra seats? And it tells us right here, seating costs $57. So that means $57 times O, the number of orchestra seats, plus balcony was B, and balcony seating right here is $110. So that would be $110 times B. And again, all of this has to be at least $7,200. So that means greater than or equal to $7,200. Okay, number 32, Jeanette is determining the seating arrangement for her big graduation party. It says circular tables C can seat 12 guests and rectangular tables R can seat 10 guests. Together they must seat at least 182 guests, the number expected. Write an inequality that describes the situation. So again, we're just writing the inequality. We have two kinds of tables, circular tables, which would be C, and rectangular tables R. So the number of guests that we can have at a circular table was 12. So that means 12 times the number of circular tables. Plus, for our rectangular tables, we can seat 10 guests. So that would be 10 times the number of rectangular tables. And that needs to seat at least 182 guests. So that means greater than or equal to 182 guests. Okay, number 33, based on the graph, which statements about the function are true? So just glancing at our answer choices, everything's talking about domain and range, right? So let's go ahead and just talk about the domain. The domain, remember, is the R, right? So it's the X values. So the domain goes from this point here at -3 all the way to this point at +6. I have empty circles at the end, so that means I'm not including those numbers. So if I write it this way, -3 is less than X, which is less than a +6. Okay, and then if I do my range, which would be the Y values, again, let me check this out. Hang on. Let me go this way. My lowest range value would be right here at -1. My highest is going to be at a +5. Again, empty circles, right? So I've got a -1 is less than my Y, which is less than a +5. All right, so now let's see what our answer choices are. It says the domain, which would be the X values, is the set of all real numbers greater than or equal to -3. Is this equal to -3? No, so that's not it. B, the range, which would be the Y values, is the set of all real numbers greater than -1 and less than 5. Greater than -1 and less than 5. So that looks like that might be it. The domain is the set of all real numbers greater than -3, right here. We're greater than -3 and less than 6. That also looks good. And then D says the range, which would be the Y. The range is the set of all real numbers greater than or equal to -1. None of these are equal to. And it says and less than or equal to 5. Again, nothing is equal to, you guys, because they were empty circles at the end. So D's not it. So let's go back. It says based on the graph, which statements, plural, not which statement, but which statements about the function are true. So we can have two true statements down here. So B and C look like they're it.